Hey, so again, Taylor expansion. So we'll be using these formulas, remember? And then the small o properties. So I'm going to put them away. And now let's focus on exercise 9. Yes, exercise 9, and we'll be solving those 3 problems. And then the words is this words. It's not amazing. I wrote it a long time ago. It's my worksheet, and yeah, it's not amazing now. It's just tiring and exhausting. So let's start. Number 1. Okay, we can do this. Number 1 is easy. So we have sine square 1 over n is equal to, I'm gonna turn off my laptop. Okay, wait a second please. Okay, now let's continue. So we have this problem, and then now let's focus. I'm gonna be doing a little bit faster. Right now in this case, around infinity, it means that n goes to infinity. So imagine here n goes to infinity. If you think this is u, because n goes to infinity, if you think this is u tends to 0. That's why we can use the formula u tends to 0. This u tends to 0, I want you to write this on the final paper because it's important. And then if you use the formula, we need, what's the question? Well, fourth order, right? So I'm gonna say fourth order here. Okay. So according to question, formula, basic formula number 4, you are going to have u minus u cubed divided by 6 plus o u to the 4. Okay, and now n square. Okay, now from here you can go to this one, u minus u cubed 6 square plus o u to the 4. Okay, I explain why. Because even though you calculate the square of this, like whenever you multiply o u to the 4, o to the u4 is gonna absorb everything with that, and that's why you can just take it out of bracket like this, only in this case. So, and now this one, if you calculate the square, it's gonna be u square, and then minus 2 times u times u cubed divided by 6. Why I'm writing this? Because u times u cubed is gonna be u to the 4, and we need to write it. But if you calculate the square of this, it's gonna be u to the 6, and we don't need to write it. So we just write this one now, o to the u4. And you can write in this way because professors understand what you're doing really well. You just keep skipping everything if it's more than the power that you need. So we have u square minus 1 over 4 u to the 4. Oh, it's 1 over 3, right? Because it's this plus o u to the 4. That's small o, remember always. And now instead of u, you just write 1 over n. So 1 over n square minus 1 over 3n to the 4 plus o 1 over n to the 4. And this is where you stop, and you will get the full score. Okay, you can see it. And now number 2. What's number 2? Okay, the question is second order, and then the problem is 1 plus sine 1 over n. And again, let me ask you, what do you see in the power? Is it x? Is it n? No, it's just 1 over n, right? Because it's 1 over n, I want you to write this. I mean, if it's u, right? Because it's 1 over n, you must write this. You must use this formula. I'm gonna type it here. E, if you have a to the b, it's equal to what? E b to the ln a. This formula, we're gonna be using this formula now. Okay, so let's continue. So e to the 1 over n ln 1 plus sine 1 over n equal to, Okay, and now if I say sine this 1 over n is equal to u, it doesn't tend to 0. That's why, because this u tends to 0, I first expand sine x. So 1 over n, 1 plus, if it's u, I need the third order. What was the question? No, third. No, it's the second order, right? Okay, if I use sine, so formula number 4, according to formula number 4, it's equal to 1 plus u plus OU. Look, it's very important. Right now in here, I'm not taking the second order, I'm taking the first order. You know why? Because e to the 1 over n and ln, because I'm gonna tell you now. Wait a bit, please. Plus 1 over n plus O 1 over n. Because right now, if you multiply 1 over, no, not now. And then in here, we have this one, right? I'll tell you now. Wait a bit. And then because my green pen, because this, how can you see it? Okay, because this u, if you think this is u, it tends to 0, we can use the formula. So e to the 1 over n, now this is 1 over n plus O 1 over n. Because in here, when I multiply, I'm going to have O n square, e to the 1 over n square plus O 1 over n square. We need the order 2, the second order, but here, because I have 1 over n, when I multiply it, I will have this one, and this comes from this formula. This comes from the property number 1. Look, property number 1. 1 over n goes inside and you add the power. Okay, and next, and now from this one you can directly go to 1 over plus 1 over n square plus O. Okay, I'm gonna write it here. 1 plus 1 over n square plus O 1 over n square. So this is your final answer. This is square, by the way. Okay, this is the final answer. And number 3. Any questions? No. You don't have to comment your questions. Don't comment, don't like the video. Just watch it and try to understand. Next, number 3. The question is third order. We have this now. Cosine 1 over n and sine 1 over n. Okay, in this case, do you see x? No, that's why we need to use e. I mean, it's the same like exercise 8, number 8, but we cannot use it right now, because if this is the question, you have to calculate it from the very beginning. So what we can do is we just have to write this e, right, sine, the formula, the same formula, 1 over n times ln cosine 1 over n. Okay, equals, and now, okay, I try to be fast, 1 over n, right? And then this u tends to 0. We know it, but you have to mention it. If you don't mention it, that's a problem. That's a very big problem. And now here you have ln, and inside this you can have 1 minus 1 over 2n square plus O 1 over n cube. Okay, I know you're asking a question, but try to understand yourself. I'm not explaining this now. I feel tired already. Okay. Now, e to the, what is it? We have this one. It's, okay, from ln we go again, because this u tends to 0. I just said tends to 0. I know you cannot see it, but that's okay, no problem. So from ln we use the formula number 5. If you use formula number 5, what are we going to have? We are going to have minus 1 over 2 n square plus o 1 over n cube. Because if you take the second, the fourth order here, you are going to have 1 over n square, and it's 1 over n to the 4, and you don't need it. So because we need only cube, the third order, I'm just taking this one here. Okay, and now next, what's next? And now time to expand sine x. If you expand sine x, you are going to have 1 over n minus 1 over 3 factorial n cube plus o 1 over n cube. I'm writing a little bit bigger because I'm not sure you can see it now or not. Plus o 1 over n cube. This is not explanation, this is just correction. Okay, and now, and when you multiply, look, we need third order, so we're gonna be skipping all the orders. So this one multiply this one, it's cube, that's why you need minus 2n cube. And this one, no, this one is n cube, and n to the 5 you don't need to write, so it's just plus o to the 1 over n cube. And if you continue, it gives you 1 minus 1 over 2n cube plus o to the 1 over n cube. Okay, that's it. And then I'm gonna put this one. Cheer up, you're not gonna fail. If you write this, you get the full score, 100% sure. Okay, I'll see you on the next video. Bye bye.